Alright guys, hope you all are doing well. I'm just still here in my quarantine. We're going to move on with our biochemistry and we're going to talk about properties of water. So water, its chemical formula is H2O. This is because water is made up of two atoms of hydrogen. So that 2 actually goes with the H, and then one atom of oxygen. And so a molecule of water looks like this, where this red atom is our oxygen and these two atoms down below are our hydrogens. So one important thing that I want you to notice about this water molecule is the fact that it is not symmetrical. We see that these hydrogens, instead of being equally spaced out on either side of our oxygen, they're located further towards the bottom. So it's almost like they're pushed down towards the bottom. So the shape of this molecule is bent. It's called a bent molecule. So the reason why this is important is because hydrogen and oxygen are connected by polar bonds. So when we get into chemistry, or when you take chemistry next year, you're going to learn about different types of bonds. But basically what happens is oxygen pulls more of the negative charge towards it, whereas hydrogen is not able to pull as strongly. So what we end up seeing is that the side of oxygen is going to be slightly negative, whereas this side where we have hydrogen is going to be slightly positive. So what we end up having is a polar molecule. And these little symbols just mean slightly. So slightly negative up here with our oxygen, slightly positive down here with our hydrogen. So it's a polar molecule. So when we have a polar molecule, think of like a magnet. So we have the north and south poles of a magnet. In this case, we have the positive and negative sides of our water molecule. So again, we have our water molecule, and it's important to note that the hydrogen side is going to be slightly positive and our oxygen side is going to be slightly negative. And so because we have this molecule where we have two different sides of opposite charges attract. So different water molecules are going to be attracted to each other. And what this leads to is hydrogen bonding. And so what this hydrogen bond is between these two water molecules is just simply an attraction. Think of two magnets being pulled together. So these two water molecules are going to be attracted to each other because of this positive region here, attraction with this negative region here to form this hydrogen bond. So hydrogen bonding is actually the reason for a lot of water's unique properties, such as cohesion, adhesion, its high heat capacity, its use as a universal solvent, and the fact that its solid state is less dense than its liquid state, or simply that water expands as it freezes. Cohesion is the attraction between molecules of the same substance. So what this means for water is water's ability to stick to itself or be pulled and attracted into itself. So this is why water has very high surface tension. So this is why if any of you guys spend time up at the lake, those water gliders, those little bugs that can walk on water, this is why they don't fall through the surface of the water, is because of water's high surface tension, and it directly relates to the hydrogen bonding between water molecules and this cohesive force. So next we have adhesion. And this is the attraction between molecules of different substances. So in this case, this is water being able to stick to or climb up different surfaces. So we see this in plants through capillary action. Water is actually drawn up those small tubes because the water is attracted to the inside surface of those different tubes. We also see this on a graduated cylinder. If you look, a meniscus forms. You see that the surface of this water actually rises up as it meets the inside edge of that graduated cylinder. So this is called a meniscus. Because the water is attracted to this other surface, it's going to stick to it on those edges, and then it sags down in the middle. So this is because of adhesion. And again, this is being attracted to or sticking to different substances or different surface. And so now heat capacity. Heat capacity is just the energy required to raise the temperature of a substance. So because water has a high heat capacity, it takes a lot of energy to raise the temperature of water, which makes water a really, really good coolant because it can absorb a lot of energy from a different substance or from a different source without changing the temperature of that water, or without drastically changing the temperature of the water. Okay, and so then universal solvent. Oops. This just means that water can dissolve lots of different substances. And last but not least, our solid state of water is going to be less dense than our liquid state. And this is actually very important because this makes it so that large bodies of water don't completely freeze through in the winter. The implications of this are huge. So it makes it so that instead of our solid sinking to the bottom of the ocean or to the bottom of a lake or whatever, and then constantly exposing a new layer of liquid water to be frozen, and that freezing and then sinking to the bottom again, and then just having this stack of ice until it's all the way frozen through, what happens is that water on top is going to be exposed to the elements. It freezes and then it floats on top, and it almost acts as a barrier between those elements and those cold air temperature and then the water beneath. So it kind of acts as like a protective layer so that the water beneath doesn't freeze all the way through. It makes it much more difficult to freeze all the way through. So again, this is important because it allows life to be sustained in these large bodies of water, and so that not everything dies out in the winter. So again, unique properties of water. Remember cohesion, adhesion, high heat capacity. It's acting as a universal solvent, and the fact that its solid state is less dense than its liquid state, or as water freezes, it ends up expanding.